Hello all the students. Today we are going to study minimal and maximum elements in a poset. We all know what posets are. We also know what hasse diagrams are. We also know that hasse diagrams are drawn only for posets, right? So in that case, what is a minimal element and what is a maximal element in a poset? Now, if I take an arbitrary set S and R is a partially ordered relation on set S. So, we know that SR is called a poset, and for this poset I can draw a hasse diagram. Now, if I consider these two hasse diagrams, the first hasse diagram and the second hasse diagram. So how do I find a minimal element in these two diagrams? Now I will not get into any complicated definitions, right? I will just tell you in a simplified manner how you can find a minimal element in these two hasse diagrams. Also how you can find a maximal element in these two hasse diagrams. Alright, so first of all, what are we talking of? We want to find out a minimal element in these two hasse diagrams. So let us first look at diagram number 1. Okay, so since I am talking of minimal elements, minimal element. So in a simple definition, if I tell you what a minimal element is that, so a minimal element in a hasse diagram or in a poset is that element to which no other element is related. Got my point? Now I will start from F. Right now we are studying diagram number 1. So if I look at F, so I can say that D is related to F. Right? Now we do not have any directed arrows here, still we know the direction in which the ordered pairs exist, right? Because I told you that in a relation the order is always from top to bottom. So in a hasse diagram we assume that the relation is going from top to bottom, hence we do not give any directed arrows. So it is quite obvious that this relation or this hasse diagram is also going from top to bottom. So that means the arrow is going somewhat like this. Alright, so arrows are going in this particular manner because the relation is going from top to bottom. So that means D, if I talk about ordered pair, it would exist in an ordered pair like D, comma B, because the relation is going from it would exist like D, comma F, because the relation is going from D to F. That means in the ordered pair would be like this, D, comma F. That is, D would be the first element and F would be the second element, right? That is why I said D is related to F. So that means I cannot write it as F, comma D. Yes, so I cannot say that F is related to D. So this concept is quite clear with all of us. So that means D is related to F, hence D or F. Alright, so next if I see, I can tell you that E is related to F. Then I know that B is related to D. Then I know that C is related to D, right? I also know that A is related to B and I also know that A is related to C. So these are the relations that exist in this hasse diagram. So D is related to F, E is related to F, B is related to D, C is related to D, A is related to B and A is related to C. But can you see any element related to A? No. There is no element which is related to A here. There is no such element. And this is what I am trying to find. Because what did I say? A minimal element that element in the hash diagram to which no other element is related. So do you find any element related to A? No, there is nothing that is related to A here. A is related to B. A is also related to C. But there is no element which is related to A. So that means A here is my minimal element, right? To even simplify the definition further, I can say that if there is no branch going further from an element, alright, like here you can see that there is no branch which is going from A. So that means if there is no branch which is going further from an element, you can call it a minimal element, or an element to which no other element of the poset is related is the minimal element. So here A is my minimal element. Now let's look at the second diagram, diagram number 2. Again, here if I want to find out my minimal elements, you can clearly see A, C and E are my minimal elements. So what are the minimal elements over here? The minimal elements in the diagram number 2 or in the second hash diagram are A, C and E. Because you can see that there is no element which is related to A, there is no element which is related to C and there is no element which is related to E. But A is related to B, C is related to B, E is related to F, B is related to D and D is related to G and F is related to G, right? But there is no element which is related to A, C or E. So that means A, C and E here are my minimal elements. Now we will see what maximal elements are. So again, we will not go into any complicated definitions. In a simple language, I can say that my maximal elements are those elements which are not related to any other element, right? Okay, so again if I see diagram number 1 or the first hash diagram, I know that A is related. I am going now from bottom to top. So I know that A is related to B. I know A is related to C. I know B is related to D. I know C is related to E. And I know that D is related to F and E is related to F. But is F related to any element here? Is F related to any element here? No. You cannot see any branch going out from F, and that means F is not related to any element. And that's what my definition of maximal elements says. That an element which is not related to any other element in the relation would be called a maximal element. So here I can see that F is the only element which is not related to any other element. Alright, so there is no ordered pair as F or something in the relation. Right? So that means I can say that here, which is my maximal element? My maximal element here is F. Right? So again, in a simplified manner, furthermore simplified manner, I can say that maximum element would be found at the top of the hash diagram from where no other branches are going upwards, right? So again, if I see my second hash diagram, now my second hash diagram here, if I want to find out my maximum element, can you tell me which is the maximal element in this hash diagram? G is the maximal element in this hash diagram. Why? Because G is not related to any other element. Can you see G related to any other element? No, because I can clearly see A is related to B, C is related to B. Then I can also see that E is related to F and B is related to D and F is related to G and D is related to G. But is G related to any element? No, G is not related to any element in this hash diagram. Hence, I can say that here my maximal element is G because it is not related to any element in the hash diagram. So, what is the difference between a minimal and a maximal element? The difference is that a maximal element to a maximal element, no element is related. So any such element to which no other element in the poset is related would be called a minimal element. And maximal element is that element which is not related to any other element in the poset. So maximal element is which is not related to any other element. And a more simplified version or one point of observation that you can see here is that if A is the minimal element, there are no branches that are going down A. So, no branches go below that element. Alright. So, if you see that there are no branches which are going down that particular element, it is a minimal element. Same here also, there are no branches going down A, C and E. And if I talk of a maximal element, you can see that there are no branches going upwards from that element. Like here F is the maximal element, so you cannot see any branches going upwards from F. Similarly here G is the maximal element, so here also you can see that there are no branches going upward from G. So that means the second point of difference is that no branches go upward from the element. So the gist of what we have studied today, the minimal and maximum elements, if I see the points of difference between the minimal and maximum elements, then in case of a minimal element, no element is related to it. And in case of maximum element, is one such element which is not related to any other element. Then the second point of difference is that in case of a minimal element, no branches go below that element. And in case of a maximal element, no branches go upward from that element in the hash diagram, which you can clearly see over here. So this is all about the minimal elements and the maximal elements in a poset.